A first-order differential equation is linear if it can be written in the form dy dx plus px of term y equal q of x, where p and q are continuous functions on a given interval. Consider the linear equation y equal x prime plus y equal 2x for x not 0. We can put it in standard form that y prime plus 1 over x times y equal 2. So this equation is not separable. And so if it is not separable, how do we solve this kind of differential equation? We can do that by using an integrating factor. And so what is the integrating factor? Starting with the linear differential equation, and I would write this as y prime plus px y equal q of x. And I mark this equation 1. If I go ahead and multiply both sides of this equation by the integrating factor mu of x, I go ahead and make this equation 2. So recall the product rule. Of differentiation when you get f of x times g of x, and we're going to do d dx of f of x times g of x. This equals f prime of x times g of x plus f of x times g prime of x. I'll go ahead and match this equation to the left hand side of equation 2. Equation 2. Then I can see that g of x is considered as mu of x and f of x is considered as y. So then g prime of x is equal to mu of x times p of x. So here then, this meant that g prime of x equal to mu of x, mu prime of x, and is equal to mu of x times p of x. So then, mu prime of x divided by mu of x is just equal to p of x. So if I go ahead and integrate both sides of this function, if I go ahead and integrate in both sides, then I get ln of mu of x is equal to p of x, the integral of p of x, plus a constant c. Right? This means I can have e to the, that means I can have mu of x is equal e to the integral of p of x. Okay, since that's integral, let's not put that c there. Okay, well now that's the case, I can drop the absolute value because the e to the exponent never going to be positive. So here we would choose that the suitable integrating factor is e to the exponent of the integral of p of x dx. Make it dx. Let's see how this works. To solve a first order linear differential equation, we first will put the equation into standard form and identify P and Q. Calculate the integrating factor mu of x. Then multiply both sides of the differential equation by the integrating factor. Then you integrate both sides of the equation obtained in step 3 and divide both sides by mu of x. If there is an initial condition, then we would determine the value of C. So let's start with our first example. dy dx equal 3x squared y equal to 6x cubed. So P of x, in this case, equal 3x squared, and Q of x equals 6x squared. Our first step is then to calculate the integrating factor mu of x is equal to e to the integral of P of x, that is 3x squared dx, that is e to the x to the third. So now we have our integrating factor. We multiply both sides of our equation by the integrating factor. So e to the x to the third times y prime plus 3x squared y equal e to the x to the third times 6x squared. The left hand side now become d dx of e to the x to the third times y equal the right hand side e to the x to the third times 6x squared. So then e x to the third times y is equal e to the x to the third times 6x squared. Integrate both sides dx, right? So then we have y times e to the x to the third, and we need to take the integral. So let's consider that integral alone. So the integral of e to the x to the third times 6x squared, and the 6x squared is not in the exponent. We will integrate using u substitution. Let u equal x to the third, du equal 3x squared dx, 2du equals 6x squared dx. So then the left hand side, the integral of e to the x to the third times 6x squared dx is equal to 2 times the integral of e to the u du, that is 2ex to the third plus c. Now put it all together. So e to the x to the third times y equal 2e to the x to the third plus c. Divide both sides by x to the third, and y equal 2 plus c times e to the negative x to the third, and I will call that c2. So y equal 2 plus c1, where c1 equal c times e to the negative x to the third. Let's take a look at the next one. Assuming that x is greater than 0. So first thing first, we need to put this into the linear standard form. So then y prime plus 3 over x y equal 4x minus 3. So here I see that here's my p of x, here q of x. So let's calculate the integrating factor. This equal e to the 3 ln of x. Since we assume x is greater than 0, this equal e to the ln of x to the third. This is x to the third. Multiply both sides of the equation by the integrating factor. So this is d dx of x to the third y equal 4x to the 4 minus 3x cubed. Integrating both sides. Divide both sides by x to the third. And we solve the differential equation. Let's say what happened if we want to solve the initial value problem. We given y prime minus 2y equal 4x plus 3. And for y of 0, that is negative 2. So first thing first, we need to find the integrating factor. We multiply the entire equation by the integrating factor. Integrate both sides. We go ahead and do factoring by part. We do integration by part for the left hand side. Excuse me, for the right hand side. So start with the right hand side. We'll let u equal 4x minus 3. Du equal 4dx. Excuse me, du. That's right, equal 4dx. dv equal e to the negative 2x dx. V equal negative 1/2 e to the negative 2x. So then the left hand side become negative 1/2 e to the negative 2x. U times v, so times 4. X minus 3 minus minus u v times du, so that is now plus 1/2 e to the negative 2x times 4 dx. This becomes negative 1/2 e to the negative 2x, 4x minus 3 plus 3. Plus 3, u is 4x plus 3. plus e to the 2x plus c. So put the left hand side and the right hand side together. So e to the negative 2xy is equal to negative 1/2 e to the negative 2x times 4x plus 3 plus e to the 2x plus c. Divide both sides by e to the negative 2x. So negative 1/2 times 4x plus 3 plus 1 plus c over plus c times e to the negative e to the 2x. Okay, expand this out and simplify. Negative 2x minus 5 over 2 plus c times e to the 2x.